All right, so we have here, we're going to graph y is equal to the absolute value of x plus 2. Remember, absolute value means it's the distance from 0. So your absolute value can never be negative. It can be positive or 0. Okay? So, same thing. With this, I'm going to choose, instead of 3, I'm going to choose 2 additional points because I want you to get the I want you to be able to see the graph completely, because if we just choose 3 points, you're not going to really see what the graph looks like. Okay? But this is what we call an absolute, sorry about that, value equation. Absolute value equation. Same thing, we're going to make a table like we've been doing before, an XY table. So this time, let's just use -1, -2, -1, 0, 1, and 2. Let's use those. Okay.
You have to use 5 for these?
I'm using it for this purpose only, so you can see what the shape of the graph looks like. Okay.
Yeah, then good.
Yeah. Yeah. Because I want you to see the shape of this graph. Because yes, if you look at the exponents to x and y, it is 1, but because we have that absolute value there, it's not a linear equation anymore. Okay? Do you have yours from last week? Alright, so let's substitute quickly. When x is equal to -2, let's go in, take the equation. Y is equal to the absolute value. I'm not going to write the equation because you already see it there. Where we see x, we're going to plug in -2. So the absolute value of -2 plus 2. But what is the absolute value of -2? 2, yes. How far is -2 away from 0 on a number line? 2. Okay? So 2 plus 2, 4. So the order pair that we're going to plot, -2, 4. When x is -1, y is equal to the absolute value of -1 plus 2, and the absolute value of -1, 1. You have 3. When x is 0, y is equal to the absolute value of 0 plus 2. The absolute value of 0 is 0. Yes. 0 plus 2 is 2.
On that problem like that, why wouldn't we just go ahead and drop the absolute value and just go ahead and turn around and just make it positive anyway?
What you mean? Drop it.
It's like you doing your absolute value of a -2.
Mm-hmm.
You know the absolute value is 2. I'm just saying, what, you just drop it, right?
Yeah. And I did drop it.
Yeah, you know what I mean? I'm just saying.
Just do it in your head. Don't worry about writing it out. Well, some need to see it. Okay? You know. But there's nothing wrong with it. It's just that it's just important for you to see why I'm putting 2 down or 1. Okay? All right, so here we go. Y is equal to the absolute value of 1 plus 2. Well, we know the absolute value of 1 is 1. And then when x is positive 2, what is the solution? When we substitute 2 in there. Yeah, take the absolute value of 2, which is 2, then we're going to add the 2 to it, so 2 plus 2 is 4. Okay? So because I have the absolute value here and it's not going to be a straight line, follow the dots. Okay? So follow your points. Here's negative 2, 4, negative 1, 3, 0, 2, 1, 3, and 2, 4. What does the graph look like?
Chicken feet.
A chicken feet.
No, that's what my boy Ross called it over there.
The chicken feet. What letter does it look like? A V, yeah.
So you're taking.
Well, chicken feet look like V, the letter V. Go ahead.
Taking what the absolute was, what it equals to, right?
Yeah, when you take the absolute, what is it equal to? When you take the absolute value of it, what is it?
That's how you graph it. Like, the first one was negative 2, 4.
Right. Right, yes. Yeah. Negative 2, 4. That's the ordered pair. Yeah, negative 2, 4.
4, then go negative 2.
Did you get it?
Yeah,
Okay, she sees it. All right, absolute value equations. The shape of the graph is a V-shaped graph. It's a V-shaped graph. You may come across that.
When you have an absolute equation, is that the only equation that's going to have, or the only graph that's going to have a V? So it's safe to say when we see that, okay.
Yes, it is very safe to say that whenever you see an absolute value equation, that it will be a V-shaped graph. Okay? Yes, ma'am.
All the absolute values are going to be non-linear.
Yes, you are right. All the absolute value equations will be non-linear because it's not a straight line. Remember, we want a straight line for it to be linear. Okay? All right. Just so that you can see that and be able to identify these. Look at example 3. We have 2x squared. And here again, for the sake of you seeing what it looks like, okay, we're going to plot 5, okay? And we're going to use the same points, negative 2, negative 1, 0, 1, 2. Now, whenever you have a power of 2, the highest power, the highest degree in the equation is 2, is called a quadratic equation. Quadratic equation. Here's our table. XY. Mimi, did you understand the plotting the points? Okay. Yes, sir.
So every time we do slopes, we have to make a chart.
Not slopes, not necessarily, but anytime that we are, until I teach you some of the shortcuts, being able to know how to, given any equation, linear or nonlinear, being able to graph it by making a table. This is the point that I want to get to you. This can always be your fallback. If you can't remember anything else, you know how to create an XY table and put some points in there, okay, and plot it that way. That's what I want you to see, okay. All right, so here we're saying this is the equation: y is equal to 2 times x squared. Because you're saying it's 2x squared, what's the understood operation between the 2 and the x squared is that times. Okay? So when we substitute negative 2n for x, you're saying y is equal to 2 times, we're squaring the negative 2. Not the 2 that was out originally, just squaring that negative 2. So the quantity of negative 2 squared, you're saying negative 2 times negative 2, which gives us what? Positive 4. And then that's going to give us 8. We'll make up 8. We'll add 8, okay? And then with the absolute value and the quadratic equation, there's some likeness to it a little bit, and I'll show you once we finish this. When x is equal to -1, you're saying y is equal to 2 times -1 squared. Square -1. -1 times -1. 1, positive 1. 2 times 1 is 2. 0 is easy because it's easy. Y is equal to 2 times 0 squared. Well, 0 squared is 0, and we multiply 0 to 2, we're going to get x is 1. Y is equal to 2 times 1 squared. Square 1, which is 1. And 1 times 2 is 2. Are you seeing a pattern? You know, what one side, on the negative side versus the positive side? Because you can already know what, you would know what, we put substitute positive 2 in, what would be y? Y is equal to 2 times 2 squared. 2 times 4, 8. Okay? Now, this is not going to be as defined as the absolute value.
You got a circle, right?
It's going to be like a little circle at the bottom. And it's called, well, a quadratic equation, the shape of a graph is a U-shaped graph. A U-shaped graph. It's a U-shaped graph, and it's called a parabola. P-A-R-A-B-O-L-A. Parabola. That's the name of it.
I mean, is that it? I mean, remember that name?
Yeah, because you're gonna hear it. You're gonna hear it again. Because we definitely will be talking about quadratic equations in here. It's P-A-R-A. That is an R. B-O-L-A. So yeah, we can't go up to 8, but we can make an 8. P-A-R-A-B-O-L-A. So here's 0, 0. We have 1, 2. We have -1, 2. We have 2, 8. So just kind of imagine that 8 was up here somewhere.
Slow your roll, man. You got 0.
Slow your roll. I think we can say this a little bit better than that.
Oh, slow it down.
Especially I'm recording this
Slow
now.
it down, Ms. Lewis.
Okay.
Ms. Lewis, 0, 0.
0, 0. Where's 0, 0?
I got it.
Okay, go ahead.
And then you went up 2.
Let's follow what we have here. I didn't go in any order. I just started.
Oh, you just apply.
Yes.
Okay.
Okay. All right. With Desi, you get what you get, right?
Yes, ma'am.
Okay. I don't think I've ever had anybody tell me to slow my roll. All right. So the graph is going to be, I'll do it my best here. It's going to be a U-shaped. It's not going to be a V, but a U-shaped graph. Okay. It's not the best, but I wanted to at least see it's going to form, it's not going to be as defined as the prominent as the V, the absolute value equation. Okay?
It's like on a test or something, does it matter? Like, are you gonna care that it's not perfect? Alright.
No, I mean, you look at mine, you know. If it's perfect, then I need a graphing calculator. Okay?